Hello, ninth graders. So we are moving on from permutations and combinations and the fundamental counting principle, which are all about finding the number of possible occurrences. So we're going to talk about why that matters as we are now delving into probability. So at the very beginning of this probability unit, or probability lesson, we're going to talk about the difference between empirical probability and theoretical probability. So the main difference is that empirical probability is the observed probability. And what that means is that where we would talk about the odds of something happening with theoretical probability, with empirical probability, we're talking about an experiment has been already manifested, and we are now looking at the results from that experiment to determine, well, if those results happen again, what is the probability that this will happen? So you're typically given the results of an experiment that you've found, and they say that the probability, my computer's really slow this morning, the probability of that event occurring. So you'll see this notation of P and then parentheses, and it might be P parentheses H of the probability of a heads of a coin showing up, or it could be P and then it could be like of women winning the Nobel Prize in mathematics. And then you can look at that as the probability of what we're looking for. So whatever's in the parentheses is what we're looking for in the probability. And it's always got this idea of a fraction. And on the bottom is the total number of occurrences. So this is where probability or permutations and combinations come in when we're talking about theoretical. Here, we're just talking about the total number of observed. Occurrences. Versus up top, so the total possible amount of occurrences, and in this case, observed occurrences. And then on top, we're talking about the total number of times we've seen E happen. So total or observed number of E occurrences. Okay. So if we were to go down here, this is a very typical way of experimental or empirical probability to be presented to you in a table. So it says that 70 gamers total were polled on their video game console preferences. Each person was asked their console preference and their education level. And so then you can see the results. So below high school or a high school grad or a college grad, Xbox versus Switch versus PS4. Find the probability that a randomly selected student would, and then here's all the probabilities that we need to find. So what is the probability that a student prefers the Switch and is a college graduate? So we need to go to this table and find out how many people are both a college graduate and prefer the Switch. And we can go to the table and we see that that number is 13. So that's 13 times that this probability has occurred. Or that this event has occurred. And then over the possible total number of occurrences observed, that would be out of the total number of people in this case, which is 70. Prefers PS4. So we can look to PS4 and there's 3 different ways that that information has been doled out between below high school grad, and college graduate. So we need to add up all of those numbers under PS4 to give us our total number of times that PS4 preference has occurred. So that's 8 plus 8, which is 17, plus 9, which is 26. So that'll be 26 out of 70. Right? No. 8 plus 8 is 16, plus 9 is 25. Out of 70. We could simplify it, but it's not that big of a deal. Does not prefer the Xbox. So now we have to go through, I'm actually going to count how many people prefer the Xbox and then subtract that from 70. So that's 24, and then subtracting that from 70 would be 46. Out of 70. Is a college graduate. So again, we go up here and we total just college graduates, which is 25 out of 70. Here it says, has below a high school education given that they prefer Xbox. So we're saying we're only looking at the Xbox people, and out of those Xbox people, what is the probability that they have below a high school education? So now our total under the fraction in the denominator will not be 70. It will be the number of people who prefer Xbox, which I think we just tallied up to be 24. So given 24 people who prefer the Xbox, what's the probability that they have below a high school graduation? And that is 13 out of 24. So that's the difference there, is that if you're talking about the whole sample set that you've been given, which the sample set is all of these people, then you would just count up the total and put them over the number of the sample set. Sometimes you're going to be having a probability that you need to find that's given something. So if you're given that this is the world that we live in, if you're given that these people all prefer Xbox, then figure out what your total number of people who prefer Xbox are. And then from there, figure out what is the probability from that other sample set. Okay. Versus theoretical probability. Theoretical probability is the expected probability. So expected probability is saying that everything has a equally likely chance of happening. So tails versus heads, boy versus girl, those types of things, equal likely chances. Now, will everything turn out to be a 50-50 chance when you're talking about those theoretical probabilities? When you're flipping a coin, will it be exactly 50% every single time? No, but there is an equal likely probability. So it's what you expect the probability to be. Okay, so again, we have this notation of P parentheses E. And again, we have this idea of what we want over what we're pulling from, what we're where we're gathering all of this information. So the total, right? It's typically what fractions are, is a piece over a whole. Sorry, gathering my thoughts. So on the top, we have the number of outcomes of E divided by the number of outcomes in the sample space. This is where your permutations and combinations come in handy, is the total number of possible outcomes, right? If we're talking about what's the probability that somebody's going to order a cheeseburger given all of these options, and then you have to go through and figure out the combination of all the different ways that they could create a meal, and then say cheeseburger is one of many options. So this is where all of that comes in.